Lesson 14.2 is calculating definite integral from a graph again. These are level 3s because they contain some semicircles, and some of the graphs, some of the functions aren't as nicely formed with the x-axis. So number 1 says the function f shown below is composed of a semicircle and piecewise linear segments. What is the value of the integral of -6 to 8 of f of x according to x? Write your answer in simplest form. So that means it's going to want fractions, not rounding decimals. So we're going from -6 to 8. So basically the whole thing. So we've got to figure out how we can chunk this up into shapes. My first thought is let's have a rectangle right here. So again, it's always with the x-axis and the function. So here's a rectangle I could easily find the area of. That would be a 2 by 1, 2, 3, 4. So that would be an area of 8, but it will be -8. Let's do, I'm going to actually make this whole thing be a rectangle. But it's kind of tricky because the only area I actually want is above the semicircle to the x-axis, so these little triangular pieces. But to find that area, I'm going to have to find the area of the entire rectangle and then subtract the area of the semicircle out of it to leave me with these. And so area of a circle is pi r squared, pi times the radius squared. But since it's a semicircle, we'll have to do half of that. Cut it in half, divide by 2, however you want to look at it. So the rectangle right now is 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4. So the rectangle is an area of 32. The semicircle is half times pi. The radius, I could take the diameter, which is 8, divided by 2. That means the radius here to here is 4. So it'd be half times pi times 4 squared. 4 squared is 16, and half of 16 would be 8. So I'd be subtracting 8 pi from that. And I would leave it just like that. So that would be that area. So we had a -8, we've got a 32 minus 8 pi here. And then last but not least, I have the trapezoid. And I would want to find the sum of the bases times the height divided by 2. So area of the trapezoid would be, the bases look like 4 and 6. And the height would be here. That would be also 4. So 4 plus 6 is 10. Half of 10 is 5. 5 times 4 is 20. Okay, and the thing about this one is every area is below the x-axis. So we're going to have a lot of negative stuff here. We're going to have the -8. We're going to have a negative of this function, and we're going to have a -20. So if I write that out, my area would be -8 plus a negative of 32 minus 8 pi. Be careful, that negative is going to have to get distributed, and a -20. So that would become -8 minus 32 plus 8 pi, and then minus 20. Combine all your like terms. -8 minus 32 is -40. -40 minus 20 more would be -60 plus 8 pi. It doesn't matter which way you write these. All right, let's try number 2. Function f shown below is composed of a semicircle and piecewise linear segments. What is the value from -9 to 7 of the integral of f of x? Write your answer in simplest form. So -9 to 7. That's where we're trying to go. Okay, so I want you to notice right here, there's a triangle being formed. And then right here is also a triangle being formed. Look at the dimensions of those triangles. That's a 3, oh, sorry, my curly brackets are not good. 1, 2, 3, 4, 5. And look, this is a 3 and 5. So they're both right triangles. They're the exact same triangle. So if you have one triangle above the x-axis and one below, those areas are going to actually cross each other out or cancel each other out and net nothing. So I don't even have to worry about those. The only thing I need to worry about right here is the area all from the x-axis to above the semicircle. And so what I'm actually going to do is divide this up so that I have a rectangle. So I'll have that area plus the semicircle area. So this is a 3 by 6 because it goes from 1 to 7. 3 times 6 is an area of 18. This is 1/2 times pi times the radius, which would be half of the 6, which would be 3 squared. So it's half of 9, which is 9/2 pi. And so right now the area would be adding all that together. That's 6 plus 9/2 pi, or 9 pi over 2, however you want to think of it. But because it's all below the x-axis, I'm going to need a negative of that whole thing. And you could probably leave it like that, but I'm going to distribute. So I got -6 and a minus 9/2 pi. That would be the total area under the curve because, again, these two pieces netted nothing. They canceled each other out.